It was the clear verdict of the judges that the overall winner of the Award of Merit is Hilti AG of Liechtenstein, in a joint development with Ceratizit SA from Luxembourg for their TE C3X drill bit. The original TE-CX drill bit comprised of 2 primary and 2 secondary cutting edges, resistance welded to a cold-rolled flute. At the time of its introduction in 1995, it was a true breakthrough in drill bit design and manufacturing technology. The companies recognized that in order to stay ahead in a competitive market and to meet the increased demands of customers, the extensive know-how gained from the original design had to be used to produce a step change in product capability and performance. The goal of the development of the gradient heads for the TE C3X drill bit was to achieve the properties required for hard and durable cutting edges, plus a more readily weldable and tough joint region in a single component. This required different hardness and toughness properties within the head, and was achieved by combining 2 hard metal grades with very different grain sizes and binder contents. However, producing a consistent bulk gradient is not as easy as just following standard processing steps after filling the compaction die with 2 hard metal powders instead of 1. There were several process changes necessary to achieve the controlled and consistent geometry and properties required of the gradient hard metal heads. Key issues addressed were control of binder chemistry and physical properties, including the careful definition and control of the carbon stoichiometry of the 2 hard metal grades to much tighter levels than in standard hard metals. Die filling and pressing for defined green density distribution. Special sinter program to control cobalt migration. Following basic research into the physical process of cobalt migration, it was found that for the actual drill bit heads, the cobalt distribution or gradient could be modified in a predictable way by changes to the sintering cycle and chemistry. The hardness and toughness gradients generated during sintering can therefore be confidently reproduced from batch to batch. Therefore, the feature which marks out the TE C3X is that it is the world's first truly mass-produced, functionally graded hard metal part. This enables the following benefits: separation of functions within a single component, metallurgical control with tighter tolerances than monolithic hard metals, geometrical control with tolerances equal to monolithic hard metals, 15% material weight saving versus the previous head geometry, energy savings due to the specially developed sinter cycle. Finally, and most importantly for the customer, the performance of the TE C3X bit has been increased measurably, whilst at the same time the robustness has been improved substantially. This newly developed powder metallurgical technology will now be applied to other components that require locally adapted properties, such as cutting and wear parts. In this way, Hilti AG and Ceratizit SA are worthy winners of the EPMA 2006 Award for Excellence in Powder Metallurgy.